What's up everyone, this is Dariusz Kalbarczyk, co-founder of MG Poland, JS Poland, AngularMaster.dev and WorkshopFest.dev. Welcome back to the AngularMaster podcast. Today, together with Manfred Steyer, who is an excellent speaker, trainer, consultant and author with focus on Angular, we will talk about cutting-edge Angular architectures. Hi Manfred, how are you today?
Yeah, I'm fine. Thanks for having me again.
Today we have the pleasure of discussing the fascinating evolution of Angular and the delightful impact it has on our applications. Let's start the show. How can the latest innovation in Angular-based architecture, such as standalone component, standalone APIs, router enhancements, functional services, benefit your project?
Well, the thing is, there are several new features that really help us to make our Angular applications and our Angular-based architectures more lightweight. For instance, there is standalone components, which helps you to work without any NgModules. And I can tell you, it really feels right because you don't have all those unnecessary indirections anymore. Just think about bootstrapping your application. In the past, you bootstrapped an app module that pointed to a bootstrap array that pointed to your app component. And now you directly point to your app component instead. So it's far more direct. You don't have those detours anymore. And this makes everything more lightweight and even more logical. Another thing that helps you is standalone APIs. It helps you to set up your reusable libraries. For instance, the router is meanwhile coming with such a standalone API or even NgRX or the HTTP client. Basically, it's just a function that sets up all the providers you need for this or that library. And the nice thing about this is it is just a function, so it is simple. And on the other side, it sets up all those internals you don't want to know about as a consumer of the library. Then there is the usage of functions. People are starting to use functions instead of classes, even for services. For instance, when we look at the Angular router, we have functional guards, just a function, not a service implementing an interface, or functional resolvers, or when we talk about the HTTP client, there is now a thing called functional interceptors. And besides this, there are even some improvements for the router. The router is now picking up default exports for lazy loading. That means you don't have to project your module, your lazy module, with .10, with this promise-based function, to the module or the routing configuration you want to lazy load. No, you can directly point to the module in question and then automatically the default export is picked up by Angular. So it's even one more piece of our mosaic that makes everything more lightweight.
How can you organize an Angular application structure without NgModules?
Yeah, that's actually a nice question, because somehow it seems to be a contradiction in itself, doesn't it? On the one side, we had modules. Now we don't have modules anymore because we go with standalone components. So NgModules are optional, but nevertheless, we want to structure our application. We want to modularize it. And so the big question is how to do this nowadays. And there it turns out that you can just go with a clever folder structure. Normally, it's quite a nice idea to structure your folders according to features. Or if your application is a bit bigger, you can structure it along your business domains. Things, areas in the real world you are writing your piece of software for, areas in the real world that are decoupled from other areas your software is about. So if we think about banking, there might be something like managing your accounts. And then there might be something like managing your stocks. Those might be different domains that are separated in your source code just by means of different folders. And you could also add an index.ts to all your folders. Such an index.ts could act as a barrel, as something that defines what the consumer of this part of the application is allowed to use. Perhaps they are only allowed to use a certain amount of building blocks, perhaps just those services and those components, but not those other components over there and those other services over there. Everything that is your little tiny secret is not exposed via such an index.ts, via such a barrel. And this allows you to have little tiny secrets, and little tiny secrets is a good thing because everything you keep a secret can be changed easily afterwards. Everything you are not keeping a secret, everything you are exposing for consumers of your libraries needs to be backwards compatible somehow. Otherwise, you break the work of other people on your team, and this is something that you should really avoid. And of course, when we look into JavaScript, we don't have something like real information hiding. No one forces you into using your barrel. Everyone could easily bypass your barrel. But for this issue, we have linters with linting rules that tell you, well, every time you try to bypass a barrel, you get a linting error or a warning. And this forces you to use the system in a way it is supposed to be used. For those linting rules, there are several libraries out there. For instance, Nx gives you the possibility to define such restrictions on the basis of libraries. And then there is quite a new NPM package a colleague of mine implemented some weeks ago. It's called Sheriff. It also helps you to enforce such boundaries between different directories. It defines that you have to use the barrel, that you are not allowed to bypass the barrel. It also defines that you are not allowed, for instance, to use a specific folder out of libraries in another folder.
What is the role of the sheriff in the context of Angular?
Well, basically, Sheriff is just analyzing your source code. It looks at your files, at your TypeScript files. It also looks at all the imports in your TypeScript files. And so it knows how one file is connected to the rest of the application, which is also just a bunch of files that is connected to another bunch of files. And so it knows how your imports work. And so they can find out if you try to import something you are not supposed to import. For instance, if you think about a general purpose presentational component, a date time picker, if you try to access a real feature from a date time picker, this could be an issue in terms of your architecture, because a general purpose component is not supposed to access a real feature. And just by finding this out, Sheriff could give you a warning or even an error message telling you, hey, please don't do this. Please don't grab over there and access something from the folder over there. Or another example, let's say you have different domains in your application. Let's stick with my banking example where you have accountant management or accounts management and stock management. And if Sheriff knows that in this folder we have everything concerning accounts, and in that folder we have everything concerning stocks, then it might prevent you to reference stocks from within the account folder. Perhaps you're only allowed to use shared stuff from within accounts or other account stuff from within accounts. And this is just found out by looking at the imports of your TypeScript files. Plus, of course, you have to configure Sheriff a bit. You have to tell Sheriff that in this folder we have everything with accounts, and in that folder we have everything that is about stocks. But for the later one, for this configuration where you tell Sheriff where to find what, there is really a nice API. You don't have to write a lot of configuration stuff. You can even work with placeholders and wildcards. You could say everything beneath this folder is a domain of its own. Everything within the domains folder is a domain of its own. And so if it finds a stock folder within domains, it knows automatically, okay, this is the stock domain. And if it finds an account folder in there, it knows, well, this is the account domain. So we have a lot of convention over configuration in there. And so it's really easy to get up and running with those restrictions.
You're listening, Angular Master Podcast. Listen, code, repeat. Everything you need to know to become an Angular super developer.
What are the standalone APIs and how does the migration process work?
Yeah, good point. So let's start with the first aspect of this. Before, when we went with NgModules, normally we just imported an NgModule if we wanted to use this or that library. We imported the router module if we wanted to go with the router. We imported the HTTP module when we wanted to go with the HTTP client module. Now with standalone components, modules are optional. That means there are not necessarily any modules anymore, depending on the style of your application. And so the Angular team needed to come up with another pattern for setting up all the providers for a given reusable piece of code. Let's call it a reusable library, like the router, HTTP client, or your own stuff. And the solution for this was just a naming pattern for functions, just returning all the providers you need. Such a function always starts with the name provide, and for the router it's called provide router. For the HTTP client it's called provide HTTP client. And for your own library it could be called provide your own library, as you want to call it. The nice thing, such a function, provide XYZ, can take a configuration object. Obviously, the router takes the routing configuration. And because of this routing configuration, or in general, this configuration object, the function might return this or that provider. Perhaps there is a special provider just referencing the configuration, or perhaps the configuration tells us that now, because of this or that configuration constellation, we need this or that additional provider. So they are tinkered in a dynamic way. They are put into an array in a very dynamic way. And besides this, we could even use this mechanism to enable optional features. Those optional features normally come with additional functions that start with the name with, like with interceptors to activate HTTP interceptors, or with preloading to activate preloading for the router. Finally, those with functions are technically just another bunch of functions returning providers. And those providers are passed into your standalone API. And so the standalone API knows, okay, now I have to also provide those additional providers in order to enable those optional features like preloading, like interceptors, like name your feature. And finally, as a side effect of all of this, our existing libraries immediately become more tree shakeable. Just because of those design decisions, the router, the HTTP client is suddenly more tree shakeable. That means our bundles will be a bit smaller. And this is somehow funny because we see this situation for years. We get a new version of Angular, we use the new features of Angular, and suddenly our application needs less space. Normally, it's the other way around, isn't it? more features, a new version of something, and everything is bigger. But with Angular, it's the other way around, and this is really cool if you ask me. So far, I talked a lot about standalone APIs for existing libraries like HTTP client or the router. However, you could implement the same naming patterns for your very own libraries or for your very own pieces of code you want to reuse somehow. Perhaps it's not even a library, perhaps it's just a fraction of your huge application, a fraction with code that is used in several use cases and or domains. And here it's also nice to have such provide functions and to have with functions for optional features, because this allows you to hide the details, the inner workings of your reusable piece of code inside of those functions. The consumer, people writing domains, features on top of your libraries, on top of your reusable code, are normally not interested into the inner workings of your stuff. They don't want to know, they even don't want to know that they have to provide those 10 services to make it possible to use your locker you've implemented 3 weeks ago. No, they just want to use the locker. And when they want to exchange something of your locker, then they just want to know about the configuration option for exchanging it. They don't want to know about using a new service with a new provider, stuff like this. No, they just want to tweak your codes by using the configuration. And so this is also a nice thing for your own codes to go with those meanwhile known naming patterns to hide implementation details and to make it possible to tweak your application. So the second question was, what happens when we auto-migrate an existing application to standalone components? Since Angular 15.2, there is a schematic that tries to auto-migrate your code to standalone. And it really works well. It really works well. Most of the times it migrates everything without any further interaction with you to standalone. However, if you use NgModules with a static for XYZ function, like for root or for child or for feature, then currently this automatism is not capable of converting those calls to standalone APIs. It's not possible because it cannot know about your library. It cannot know that what was for a feature in your library formally is now provide store in the case of Nginx. Of course, we could tell those automatism about some libraries that are heavily used, like the router, like the HTTP client, but besides that, it cannot know about each and every library, and so very likely you need to do this by hand. You tell the converter to convert what's possible, and the rest needs to be done by hand, which is not that a big job. Normally, it's just about replacing calls to module for a root, for a child, for a feature, to a call of another function, and then pops your own. So it's all about hiding implementation details.
What should you know about routing and lazy loading in Angular?
Yeah, it's also a good question, because formally, for some reason, the router was really intermingled with NgModules, wasn't it? In order to do lazy loading with the router, we needed to point to another module. We called it a lazy module. And this lazy module one more time imported the router module with for child, and then for child was pointing to your lazy router config. So it was really a huge amount of indirections. And just if you hear how I have to explain it, it becomes obvious this was not really a good design. Funnily, we did not question this anymore because we were used to it. We learned this in our Angular courses and then we just used it. But if I have to explain it with words, you immediately see, well, somehow it was with a lot of indirections. It was not that class clear. And funnily, and also luckily, now with standalone components, those unnecessary indirections are gone away. Now, our main routing configuration directly points to lazy routing configuration, to the configuration of lazy parts of your application. You directly point over to your lazy router config, and that's it. So it really feels right, and it's also easier to learn. Besides this, besides pointing to a lazy router config, you could also directly point to a standalone component. In this case, lazy loading is a bit more fine-grained because that means you directly load this component and not this bunch of component referenced by a lazy router config. I think we will see in the future what people will prefer. Currently, I prefer doing it in a more coarse-grained way, loading a bunch of components that somehow belong together, that are somehow necessary for one given feature.
What are the key aspects of functional services in Angular?
Yeah, so for me, functional services is just an umbrella term for using functions as services. You can, of course, do this with your own services, but also the Angular team started to use this pattern. For instance, if we think about the router and its guards, formerly, a guard was a service that implemented an interface. That interface forced you into implementing a specific function or a method. Then the whole service was registered as a service, it was provided, and then the service or the token for it needed to be put into the router config. And one more time, just by listening to my words, how I need to explain this, it becomes obvious that also here we had a lot of unnecessary steps, a lot of indirections. Now, with functional guards, you just define a function inside of your router configuration, and that's it. It's really simple, it's really straightforward. Normally, this function is a one-liner requesting another service and then calling a method on this service. If it is not a one-liner, then you can put it into an external function. You can create another file with another function, export the function, and reference the function inside of your router config. But still, this is more straightforward than the game with the class-based service that implemented an interface and so on and so forth. So it's really more direct. It hurts less in the brain, and it's easier to write, easier to read, easier to learn for new colleagues. And we have the same situation with resolvers in the router. We have the same situation with HTTP interceptors. And as mentioned before, you can, of course, do the same with your very own services. Just use value instead of use class. When you point to a class, of course, you have to go with use class. If you just point to a function, then you have to go with use value. Especially for all your services that only consist of one function. This functional approach is really a nice one.
Will signals play a role in the performance and functioning of the described elements?
I think so, yes. I think so. Also, signals make everything a bit more straightforward. So for me, it's another piece of this huge mosaic that is about simplifying Angular. So at first glance, it makes working with reactivity simpler. We don't have to work with RxJS anymore. We don't have to subscribe. We don't have to set up our long pipes. We don't have to think about how to unsubscribe. Signals simplify all of this, and you don't need to unsubscribe from signals anymore. Of course, signals are quite simple, and that's why they are not suited for each and every use case. There might be some use cases where you still want to go with RxJS, and in those cases, you really can go with RxJS. there are bridging functions converting from signals to observables and vice versa. So feel free to use our XJS if you have to use it or if you want to use it. But you don't have to use it anymore in most of the cases. I would say in, let's say, 80-90% of the cases, signals are good enough and simplify your whole reactivity story. The second thing is signals not only make reactivity simpler, but they also allow us to get rid of Zone.js eventually. Especially, let's say, next year, when we have a lot of new signal features like signal components, then you can totally start a new project without any reference to Zone.js. Currently in the transition, it's quite likely that you have existing code you don't want to rewrite immediately or don't want to rewrite at all the signals. And that's fine. You can stick with this existing code. This is one of the promises the Angular team gave us. They won't break our stuff because they know Angular is heavily used in the enterprise environment. And when it comes to enterprise software, we are talking about software that needs to be maintained for years or even decades. So everything that is there will still work, and you can mix in the new stuff with signals, which makes the new stuff more lightweight. And if you eventually start a new application, then you can go all in with signals, and this allows you to leave Zone.js away. That's the second aspect. A third aspect is, since about, I think, 4 days, give or take, we have the RFC for signals. And this RFC talks about a new building block, namely about a signal component. And the signal component will be the key for leaving Zone.js away. And besides this, the signal component is also simplifying the current API around components. For instance, working with inputs becomes a bit more straightforward. You don't need decorators anymore for imports, and imports are automatically signals. So you have something like an reactive input. I think I said import before. Sorry about this. I wanted to say input in the sense of properties and property binding. So no decorators anymore, and they will be signals automatically. And this simplifies working and listening to changes. That's one aspect. Another aspect is that now we can pass down a signal to our child components and to our grandchilds and our great-grandchilds and so on and so forth. And this means we don't need property drilling anymore. At least this is one way to prevent property drilling, to inform the whole relationship here, our children and grandchildren and grand-grandchildren, about something that changed. We just pass down the signal, and everyone who is interested into a change of this value can listen to the signal. So to answer your question shortly, yes, I think signals tie into the story, and signals will make everything more straightforward. So I think there is a mid-term perspective, or let's call it a short-term perspective and a mid-term perspective. In the short term, signals will be one way to work with on-push, will be one way to improve on-push change detection. It will be more or less the performance we already had with observables and the async file. In theory, the performance is even slightly better because with signals, we can leave some checks away we needed with observables. But I think this is more theoretical. I don't think you will immediately experience this when working with your piece of software. But in theory, yes. The midterm perspective is going without zones, going with signal components. In this case, the performance will be even better because signal components will allow us to do change detection on a view level. That means we don't need to check the whole component anymore. Angular can find out if a view was changed. And a view in this sense is, let's make it simple, is everything that is within a template and or a structural component. So the contents of a for loop can be re-rendered. We don't need to re-render the whole component when there was a change. Or the contents of an if can be re-rendered. Or if you write your own structural directive like an let, then the contents of this let can be re-rendered without the need to re-render the whole component again. This makes everything more fine-grained, and also because of this, the performance will become better. And besides this, we don't need to check our parents anymore. Currently, even though we go with onPush, every time all the parents of the affected components are checked, because Angular is going top-down. It starts with the root component and it climbs down to all the components that have been marked for check. And this is also not the case anymore, because signals directly tell us, hey, here in the bottom right corner, there was a change. Please look at this very view, at the contents of this for loop, for instance, and update it, leave everything else alone. So yeah, in the midterm, when we get signal components, the performance will be better. In the short term, it will be about the same as on.
As we wrap up today's podcast, I'd like to extend my heartfelt thanks to our esteemed guest for their insightful participation. It's been a pleasure having this conversation, and we've certainly learned a lot. Manfred, thank you so much, and see you next time.
Yeah, see you next time. Thanks for having me.
I'd also like to invite our listeners to tune into my second show, JavaScript Master Podcast, where we continue exploring the fascinating world of web development. Don't forget to subscribe to our podcast on your favorite platform. We appreciate your support, and we look forward to sharing more engaging discussions with you in the future. Thank you for joining us today.